Integrated municipal solid waste disposal system. With the ever-increasing population and urbanization, the country is facing a huge challenge in waste management. The volume of waste is projected to increase from 62 million tons at present to about 165 million tons by 2030. Dumping of garbage at the current rate without any treatment would require about 1,240 hectares of landfill area per year, and with projected generation of 165 million tons of waste by 2030. Setting up of landfills for 20 years with 10 meters height will require 66,000 hectares of land. This necessitates the importance of scientific solid waste management in today's context. Waste to energy is an option for sustainable solid waste management, and it is the need of the hour to realize its potential as one of the most significant future renewable energy sources, which is economically viable and environmentally sustainable. Studies suggest that the MSW generated in India mostly consists of a large fraction of organic wastes, 40–60%. Unscientific waste disposal practice in landfill site produce greenhouse gas, GHG, emissions and other air pollutants. Methane emitted from landfills is one of the most important contributors to GHGs. Scientific and most popular techniques for disposal of wet waste include composting and biomethanation plants. As per information available for 2013-14, compiled by CPCB, municipal authorities have so far only set up 553 compost and vermicompost plants, 56 biomethanation plants, 22 RDF plants and 13 waste-to-energy (WTE) plants in the country. Many of these plants have experienced failure due to several issues related to the segregation of waste, low calorific values of the waste and challenges in the operation and maintenance of the plants. CPCB 2013-14. The CSIRCMERI, Durgapur has developed an integrated municipal solid waste disposal system, IMSWDS, for disposal of solid waste in a scientific way in line with Solid Waste Management Rules, SWM, 2016 prescribed by Union Ministry of Environment, Forests and Climate Change, MoEF and CC, Gov. of India. The integrated municipal solid waste disposal system starts with the mechanized segregation of solid waste. The mechanized segregation system segregates solid waste into metallic waste, metal body, metal container etc., biodegradable waste, foods, vegetables, fruits, grass etc., non-biodegradable, plastics, packaging material, pouches, bottles etc., and inert wastes, glass, stones etc. The biodegradable component of the waste can be decomposed in an anaerobic environment popularly known as biogasification. In this process, biogas is liberated through conversion of organic matter. The biogas has a typical volumetric composition of 55 to 60% methane and 35 to 40% CO2 with traces of moisture and other impurities such as hydrogen sulfide, and it can be used as fuel for cooking purpose. The gas can also be utilized in gas engine for generation of electricity. The residual slurry is a good organic manure and utilized as fertilizer. The organic waste is also converted to compost in a natural process known as vermicomposting by introducing earthworms. The vermicompost is utilized in organic farming. Biomass waste such as dry leaves, dead branches, dry grass etc. are disposed of by first shredding it to a suitable size followed by mixing with the slurry of the biogas digester. This mixture is feedstock for briquette, which is utilized as fuel for cooking. These briquettes are also being utilized in gasifier for production of syngas, which is a mixture of mainly carbon monoxide and hydrogen. The syngas has calorific value equivalent to that of biogas and hence can be utilized in gas engine for generation of electricity. The ash produced from burning of briquette is mixed with cement and water in an appropriate proportion for production of bricks, which is used for construction work. The polymer waste consisting of plastics, sanitary waste etc. is being disposed through two main processes, i.e. pyrolysis and plasma gasification. In the pyrolysis process, the polymer waste is heated to a temperature of 400 to 600 degrees Celsius in an anaerobic environment in presence of suitable catalyst. The volatile matter from the polymer waste comes out as a result of heating, which on condensation gives pyrolysis oil. Different heating mechanisms such as solid fuel-based, liquid fuel-based and gaseous fuel-based in standalone mode or in combined mode have been developed for carrying out the process. The pyrolysis oil is termed as petro-alternate fuel, PAF. The crude pyrolysis oil after purification can be used in industrial boilers, generators etc. for heating, power generation purposes. The non-condensed syngas from the pyrolysis process is fed to the gas engine for generation of electricity. The solid residue known as char is mixed with the biogas slurry for production of briquette. These briquettes are being utilized for heating the reactor of the pyrolysis process, thereby making the process self-sustainable in terms of fuel. The polymer waste or sanitary items are also disposed of utilizing high-temperature plasma. The plasma gasification process converts the waste into syngas, which can be utilized for generation of electricity. The residual ash is mixed with cement for preparation of bricks. The construction and demolition (C&D) waste is crushed in a jaw crusher and then segregated in different sizes in the trommel. The fines are mixed with cement and water in appropriate proportion. The prepared mixture is then filled in the mold cavity of brick press. Then it is being pressed using hydraulic press to give it a proper shape and compaction. The bricks are cured to achieve desired strength. Finally, the prepared bricks are tested for engineering properties. The ready bricks are being used as construction materials. The oversized crushed materials are used as aggregate in PCC road making.